Ladies and gentlemen, once again, welcome back to Q Manufacturing. We're going to continue where we left off last time with our thickness experiments and try and do it properly this time and actually have a look at how similar materials of different thicknesses bend. We're getting rid of one variable, which is the material type, and we're just sticking with a similar material. In this case, we're using Divinyl. I think it's 80 kilograms per meter cubed. It's pretty much similar to a PVC in terms of rigidity, but it's got a bit more other properties, which I'll throw up some information about here so that you can see it's pretty good stuff. I'd like to say this video is not sponsored, highly caveated, not sponsored, but I would like to thank the guys down at Play with Carbon in Victoria. I bought one sheet off them and they gave me a bunch of offcuts from other sheets so I could do this. And it's very nice of them. Once again, not sponsored, just Play with Carbon being nice blokes and help me out. So without any further ado, let's get on to it. So the first sample size we'll be running with is a 5mm thickness. The skins this time are actually 0.88 of a millimetre. That's just quality control in my making of new skins. So there's no carryover of skins from the last time. So first up we have the 5mm thick Divinyl 80. It's 80 kilograms per metre cubed. And we're going to put 50 grams of weight on it. So next up we have a 10mm foam core, and once again starting with our 50 grams. Next up we're going to have a look at a 12mm thick core. You may have noticed in that last one we didn't get much deflection, only about 0.79 millimeters, so I'm just going to call out the end deflection of this one, just so you don't miss out on all the excitement. So first up, as always, 50 grams. And that's moved 0.72 millimeters down. Alright, I'm going to level with you here. That's actually the second time I ran the 12mm part. And if you have a look here and we turn it sideways, you can see autofocus. Okay, if you have a look here, you can see it's actually tapered down a bit as it comes along, so down. I squashed it when I put it in there. So the first time I ran it, it came out to get 1.21 millimeters deflection, which is actually 50% more than what the 10mm thick part got, which is a little bit concerning. And I started thinking that I've done it again, I've made you guys watch this video and we're getting nothing out of it that we didn't get last time. I actually thought that we were going to end up with a U-shaped curve where the stiffness of the foam contributes until the foam becomes too thick, that the stiffness of the foam is now not stiff enough to actually transfer the shear properly. So you end up with a positive benefit until you get to a certain level of thickness and then it starts going negative again, which there very well may be. And that might be something I'll look at in the future if I can get a lot of different thicknesses. But I don't think we're seeing that at the moment. So yeah, once again, just crushed that little bit of area there and it gave quite bad results. You can probably see if I squish it down. Yeah, I can't squish it down right now. My finger's not strong enough. The results weren't good enough. I will talk more to that at the end. Where I actually have a plan for next time. Next one we're on to is 16mm thick foam core. Same core type, same method, 50 grams. Alright ladies and gents, that's a 0.54 for the 16 gram one. So I'm just going to put the charts up here and you should be able to see that we've got a clear trend that the thicker you go, the stiffer it is, which comes back to my original narration in the first video of Nadar. We all know that. However, I put some numbers to it. The exact numbers I can't say off the top of my head because I'm talking in front of this right now, but they will be here as relative stiffness ratios. But the interesting point and the most important point here is the weight differences between those four pieces. For the 5mm thick part, we're at 9.7 grams. And then for the 16mm thick part, we're at 12.3 grams. That's approximately a 30%, roughly, numbers on the side here, weight increase. However, if we look at the stiffnesses, we've gone from 2 millimeters deflection down to 0.53 millimeters deflection, which makes it approximately 4 times stiffer. So for a 30% increase in weight, we've gained 4 times the stiffness. Now this is also open-sided, so you can see on the side here that there's actually nothing here other than foam. There's nothing to transfer the shear between this top layer here and this bottom layer here, other than that foam core, and that foam core is significantly weaker than fiberglass or carbon fiber or any other composite material for that matter. So to make it better, what you can do is enclose these sides here, or have an I-beam structure running through the center, and then just use the foam to stop buckling. There's a multitude of different ways that you can design this to make it even stiffer than what I'm demonstrating to you today. And I'm actually going to look into those things in future in this series to show you some of the different things you can do to close off foam cores or to change cores, or even look at honeycomb. I have some of that lying around now, balsa wood or other core types that will give you that increased stiffness for the weight, because that weight saving is really what you're after here. You've got a tiny little increase in weight but a massive increase in stiffness, and also a massive cost saving. Using core materials inside composite structures saves a lot of weight and also saves money. I said before that I was concerned about the crushing forces experienced down here, and if you look back at the last video I did, I'm not the only person who's concerned about that. In fact, there was someone who called me out on it, and rightfully so. So what we're going to do is this entire get up here, this is gone. Next video will not use this. I'll have something else. It'll be a 3 or a 4 point bending rig. It's in design at the moment. I get to use my welder. Yay, I love my little welder. And I get to make some stuff, and that's cool. That's going to get rid of the crushing that we get out of this area here. It's going to extend the lever arm we're looking at a little bit, and it's going to allow us to use more force than just the 500 grams. And it means I'm not going to have to lay that 500 gram weight down each time that we need to do it. So watch out for the next one. We'll have a look at some different core materials, and we'll even have a look at some closed and open sided cores, so we can see the differences that closing off that structure makes. Thanks for watching, guys, and I hope you have a good one.